All right, we are in section 2.2, working with function. So we'll do some basics of some function stuff today, and then we'll go through and add some different things to it as we go along. Your basic definition of a function. Function implies that every x corresponds to only one y. And we'll go through some different types of examples to help you get that down, but every x corresponds to only one y is that basic definition. Most of what we deal with in this course are going to be functions, and that's stuff you've seen before. The most basic type of function you saw in the past was a line. That's a function, okay? In secondary 2 and part of secondary 3, you saw parabolas. Those are functions. Okay, you know what those kind of look like and things like that. So you've seen a lot of them before. This is just going back to that basic idea of it. When it comes to functions, they have a domain and a range. Do you remember what domain was? I remember. Domain was x. The domain was what x can be. So then what would range have to be? Y. All right, so what y can be. And the way that you can remember it is it's always alphabetical order. DR, X, Y. So X goes with domain, Y goes with range. Okay? After this class, when you go to whatever math class you're in, it will still be alphabetical order no matter what you're working with. Whether it's in trig or college algebra or calc, it still stays alphabetical order, everything in there. So it can help you keep some things straight. So let's look first at a set of points. I'm going to say set of points, and this is just what we call a relation. So if I give you a set of points, 2, 6, negative 1, 4, 0, 5, 1, 7. So just to make up some generic 4 points there. So domain would be x, range is y, and if it's a function, every x corresponds to only one y. It's our general definitions. So if I look at this, domain would be 2, negative 1, 0, 1. So the domain would just be all the x values, whatever x can be. So in this particular situation, x can only be the 2, the negative 1, the 0, and the 1. That's the only x values I've got. Right, pretty basic there. The range would be looking through and finding the y values. Well, the y values would be 6, 4, 5, 7. Right? Now, a lot of times when we have the domain and range, you'll see them written in numerical order. It really doesn't matter. A lot of times when you're just specific values, you just write them in the order they show up, something like that. So then the question comes in, would this relation or this set of points represent a function? So in other words, does each x correspond to only one y? So in other words, 2 goes with the y value of 6 and no other y values. Negative 1 goes with the y value of 4, no other y values. Same for the other two. So yeah, this is a function. This is representing a function, these 4 points are. Let's change our points. Let's go 3, negative 2, 0, 4, 7, 1, and let's go 5, negative 2. Again, just 4 points. We're going to look at domain, range, and function. You can scan across there. Domains are x values. Domain would be, I'm just going to put D for domain, 3075. Does that look okay to everyone? Range, -2, 4, 1. All right. Now you could rewrite again the -2 at the end. So if you wrote, say, -2, 4, 1, and then -2, that's still correct. We just don't need to rewrite one we already have. It will still be correct. Now here's the question. What do you think? Is that a function? Does each x correspond to only one y? How many of you say yes, it's a function? A couple. How many say no? How many have no clue? You didn't vote. Oh. You think function or not? No function?
Yes.
Yes, function. Okay. Here's the thing. Whether you're saying yes or no, all of you should be glued into that -2. Because that looks like where it's causing a problem, right? You're seeing a repeater. So if it's a function, then that's okay. If it's not a function, then that's a problem. But regardless of which one you're answering, that's kind of cluing you in. Something's going on there. Okay? Now in this case, here's where we go with the definition. Every x corresponds to only one y. So if I've got an x value of a 3, what y value does it go to? -2 and no other y values. So that x value only goes with that one y value. This x value of 5 only goes with the one y value, not a different one. That means, yes, it is a function. Now that's where it gets kind of confusing. And at some point or another, it gets confusing for all of us. But if anything, that should have been where you're looking. Hey, 3 -2 and 5 -2, if it's not one, it's right there. Something's going on. Let me give you an example of one that's not. Okay. Let's go 2, 5, 3, 1, 2, 7, 8, 9. Still 4 generic points. You look across, domain's pretty easy. Range pretty easy. The x values, the y values, not too bad there. Domain, I'll need parentheses. 2, 3, 8. Again, if you rewrite the 2, that's still correct. I just didn't because I already had it. Range, 5, 1, 7, 9. All the y values. And then is this one a function? And this one would be no. And when we're trying to decide yes or no, we're kind of doing the same thing we did back here in number 2. Our eyes are glued on that repeating value. Right? There's a problem that's got to be there. Okay. This one's a no because I have an x value of 2 that goes with more than one y value. The 2 goes with the 5 and the 2 goes with the 7. So I have a singular x value with more than one y value. That's not a function. That didn't happen in this case. 3 went with -2. Well, 5, that's 2 different x values, not one x value going to the same. Does that make sense to everyone? A little tricky on the definition. Here's something you should remember from somewhere in the past. You should remember a vertical line test. Vertical line test. If vertical line intersects graph more than once, then not a function. A vertical line intersects the graph more than once, then it's not a function. Now, it's probably been a little while since you've used that vertical line test. Let's kind of look at some graphs here and investigate. So what we're looking at, if we get some pictures up here, we're just trying to decide, does the picture represent a function? So here's an old basic one for us, a parabola. All right, so the idea would be, if you draw a vertical line anywhere through here, will it intersect the graph more than once? And it will not. So that means this is a function. That was your vertical line test. So this is definitely a function. Just write function, question mark. It does pass that vertical line test. How about a graph like this? Would that one be a function? Will it pass that vertical line test? Just picture vertical lines going through, never hits it more than once. Hey, that's a function. This is your old basic linear graph. Yeah, that's a function. No matter where you draw a vertical line, it'll pass. Okay. How about a circle? Is that a function? No, because you can draw a vertical line, hits it twice, right? If you can draw a vertical line somewhere and it hits it more than once, it's not a function. Now, that's not saying that the circle's not a graph. It's certainly a graph. Okay? Now, you can graph anything you want, but not everything you graph's a function. Kind of like you can draw any quadrilateral, any four-sided figure you want, but not every one you draw is going to be a square. Okay? So a function is just a special type of graph. How about this one? That'd be a function. Vertical line. Once. No matter where I draw it, hits it once. Almost looks like it kind of goes vertical here, but it's angling out, so just that one time. Right, so that's a function. How'd that go? Is that a function? No. Definitely not a function. Everybody okay there? Now let's use this last one to kind of explain this definition. This definition gets to us sometimes. We see it in points, and we saw some things repeat where we're trying to decide which one's which. And we're going to do that, okay? So let's use this example to actually show a picture of that definition. If I were to put that last graph on a grid, so something like that, okay? It's not a function. We already said it right here. It's not going to pass the vertical line test. Here's why. Let's say I've got an x value of 2. It's corresponding to 2 different y values. So I've got an x value going to more than one y value. That's why it's not a function. All right, so that'll tie it back to this definition for us. Does that make sense to everyone? Okay, now let's pull domain and range back in with our graphs here. I'm going to say that point is 4, 6. And of course, that's the origin, 0, 0. Now the question is, first off, would it be a function? Does that pass the vertical line test? Yeah, no problem there. That's a function. So I'm going to say function. Yeah. Domain. All right, so we look at a graph. Right? Remember, domains are x values. Think of a graph. Your x values run left to right. Number line, left to right. So if I look on the far left, the smallest x value is right here, and that's 0. The largest x value going across is 4. 0 to 4 would be my domain. We use brackets because we actually included them. They're both colored in. Range, smallest y value is 0, largest y value is 6. So y's run bottom to top. So I'm looking at my graph. What's the smallest y value right here? 0. To what's the tallest y value or highest? 6. There's my range. Everybody okay there? Let's give it a different look. I'm going to say that point is 5, 3. And I'm going to say this point is -7, -5. So first up, is it a function? Yeah, that passes the vertical line test. No matter where I draw that vertical line, it's going to pass. Definitely a function. Domain and range. Now, domain being x, range being y. That should sound very familiar to you. Some of you might not be as familiar with the interval notation. We're writing it like this. So this previous problem, I gave you the colored in dots. Now I've got one that's open and one that's solid. But still I'm looking left to right. Smallest x, -7. Parentheses around it. Moving to the right, the largest x is 5, bracket. I'm including the 5. I'm not including the -7. Now, if that looks a little bit strange to you, if you're not used to that notation, here's something you have seen somewhere in the past. You should remember doing like your old number line graphs. If I said like x less than 2, I remember doing like an open circle and coming back. Does that make sense? Okay. You can also do it with a parenthesis coming back. Whereas if it was equal to, that would be colored in, right? And then this would be a bracket. That's where that's coming from. So you're taking this old number line idea over into that two-dimensional graph. Okay, there's where that parenthesis and bracket kind of coming in. So range, smallest y is -5. Up to the largest y, 3. Bracket on the 3, parenthesis on that -5. So I gave you ones there that had an open or closed circle on the end. If you see arrows on the end, that means it just keeps going. Okay? So if I had something like this, that was just a basic parabola. That'll work. Some generic parabola. And yeah, that's a function. Nothing wrong with that. We know it's a function. Passes that vertical line test. Domain would be -infinity to infinity. So the arrows indicate that it just keeps going. So as it's going up, it's moving out. So as it's moving up here, it's going to cover all these negative x's, all the positive x's. We're going to cover them all. Infinities always have parentheses because we never actually get there. That hard closed dot, that bracket, means we got there. Range, 0 to infinity. Bracket on the 0. So I'm going right through the origin here. So there's my smallest y value. And then the arrows are going up, so it keeps going forever. Are you okay with that? Now, I will tell you this. Some of the pictures in this textbook, they'll look like this. To you, that means there's arrows on the end. Okay? If there's not an arrow on the end, you'd actually see a nice dot there to kind of indicate. Right, so this would still mean it keeps going as far as some of those pictures. So I'm just kind of giving you a heads up with the way some of those look in this textbook. They do keep going for that. All right, if it's stopping, we'll actually see a dot sitting there. All right, the graph quit. Okay. Let's get a strange one here. Let's say that's 2. Go this way. We'll say that's -2. We'll go this way. Different look, same idea. First question. Now both these graphs are combined. They're both part of one whole graph. Would it be a function? No, we're not going to pass the vertical line test. It still will have a domain and a range though. Right? Domain and range is just what x can be and what y can be. It's not dependent upon whether or not it's a function. So if I'm looking left to right, this will not cover all the x values. I can see I got them all back here to -2, and then I'm skipping this chunk in here between -2 and 2. And then I pick up again at 2 going forward. The way that we'll write this, -∞ to -2, parenthesis, union, bracket 2 to infinity. Now, it's expected you walk into this class and you've seen interval notation before. It's not expected that you're proficient at it and done a lot of it. Okay, so let's investigate it. And if we're having some trouble, we can work on it. Okay, what you should easily see is, hey, we're not covering these x values in between here. That was left out of the graph. Okay, so we've got to find a way to represent the other. I'm just looking left and right. How far, or what's the smallest x? -∞. Coming to -2. Parenthesis, because it's an open circle. Okay. And then I'm skipping all the way over to here, picking up 2, bracket because it's closed, going all the way to infinity. The union symbol isn't anything special. It just means we're joining more than one part. We're saying the domain is this piece back here and also this piece over here. That's all the union symbols mean. Now, we only have one interval in all of these over here, so we didn't use a union symbol. Range. Well, this is coming out, it keeps going down. So the lowest y value is just going to be -∞ because it keeps going down. The highest y value, likewise, keeps going up, +∞. I don't have any y values left out from bottom to top here. I still covered everything in there. The one question that might be left out is, hey, you left out a 0. I picked it up on that side. So I did still include that 0. Okay there. Last part about our functions. Okay? And this will relate to the bonus question on the test. Function values. And typically each test I'll give you a bonus question. And usually it's something we did previously or the next unit or something you've done before just to see what you think. Doesn't hurt you if you don't get it right. Function values. If I have f of x equals 3x minus 2, this is your old function value idea. If I want to find f of 2, that means I'm substituting 2 for x. So I'd have 3 times 2 minus 2 is 4. Now, whether or not you got the question right, does that kind of look familiar now? In the past somewhere? If I want to find f of 7, 3 times 7 minus 2 is 19. Okay there? Here's where those function values are going to matter. Notice this is x. So that means 2 is the x value, right? When I'm replacing it, 7 is the x value. What you get out is the y value. So this would correspond to the point 2, 4 and this one to the point 719. Put an x in, you get a y out. Put another x in, you get another y out. Sound okay to everyone? If we see more than one x in there, give me a different one here. Let's go with p of x equals, I don't know, let's go 2x squared minus 4x. One up there. Well, if I want g of 3, 3 is going in for x. 2 times 3 squared minus 4 times 3. And then I've just got to simplify that out. So that would be 18. 9 times 2 is 18 minus 12, 6. Same idea as the first, and we just have more than one x to go in. Does that look okay to everyone? Okay, here's what we'll be adding to it in this class. So kind of some old ideas, put a value in, get a value out. What if I wanted to find g of a? Well, instead of substituting a 3, I'm just substituting a. It's the same idea. 2a squared minus 4a. A still went in for x. No tricks there on how it's done. What's new is sometimes we're not used to substituting a variable. It's just a letter. And replace it. We could even do something like a sum. That looks really weird. We're going to take an x and then put an x and an h in. Follow the same thing. What we got used to was, hey, whatever we see here is replacing x. I don't care what it is. If it's an a, it's replacing x. So now if it's an x plus h, 2x plus h squared minus 4x plus h. Still replacing x. Now on that one you can do some multiplying and kind of simplify it, but that's still the base form as far as what we're going for. So we're taking something pretty basic for us, put a value in, understanding a little more advanced that we're really talking about a point on a graph, because that was x, y value came out, x, y value came out. So then more advanced, whatever's in here is being substituted for x. And we'll work with some of these guys more, but we want to realize that this is not any more difficult than finding g of 3. It's the same idea. I'm just not substituting a number, I'm substituting a variable. Still replace that x. It looks like something completely different, but it's not. Okay? Just like when you look at some of these and you see these parentheses and brackets, it looks like something you've never seen before. Well, you have because you did those old number line graphs. Translating into this one. All right, let's take a look at homework here. On your homework.